Monitoring freight shipments along the Gulf Coast is a pain. For specific, high-value loads, I needed real-time updates beyond what the standard carrier websites offered. I'm talking about knowing the exact moment a vessel clears a certain port, or when a truck is truly out for delivery instead of just en route. The problem is, these websites are all different, often clunky, and rarely offer push notifications for the granular details I cared about. Manually checking 5 different carrier portals multiple times a day was a waste of time, and an even bigger waste of mental energy. My solution had to be automated, robust, and notify me instantly when a significant status change occurred. I decided to build a Python-based system using Playwright for scraping and Twilio for notifications, effectively creating my own custom real-time shipping tracker. The core of the system revolves around Playwright. I chose it over Selenium for its modern API, better async support, and built-in browser management. Each carrier's tracking page presented its own unique challenge. Some required logging in, others were simple form submissions. My first step was to identify the specific input fields for tracking numbers and the button to initiate the search. I created a trackingscraper.py module, which contains a class for each carrier. Each class has a getStatus tracking number method. Inside this method, I use Playwright's page objects. For example, for one carrier, it might be page.fill input tracking number followed by page.click button track button. The crucial part was then waiting for the new content to load reliably. After submitting the tracking number, the next challenge was parsing the status. Shipping status updates are notoriously inconsistent in their phrasing. One carrier might say delivered, another finalized delivery, and a third consignment complete. I needed to normalize these. I extracted the relevant text content using Playwright selectors, like page.locator div.status message.innerText. Then, I implemented a normalized status function using a dictionary of regex patterns to map various carrier-specific phrases to a standard set of statuses: pending, in transit, out for delivery, delivered, delayed. This allowed my system to understand status changes uniformly, regardless of the carrier's idiosyncratic phrasing. To manage multiple shipments and track their state over time, I needed a persistent store. I opted for SQLite, primarily for its simplicity, zero configuration, and robustness for this type of application. I designed a shipments table with columns like ID, tracking number, carrier, current status, last checked at, desired status, and notify phone number. The current status and last checked at fields are updated on each poll. The desired status column is crucial. It lets me specify what I want to be notified about. For instance, I might only care when a shipment goes from in transit to out for delivery, or when delayed appears. The polling mechanism runs as a background process. I have a simple Python script, poller.py, which wakes up every X minutes configurable, currently set to 15 minutes for most shipments. It queries the SQLite database for all active shipments, iterates through them, instantiates the correct carrier scraper, and fetches the latest status. A key design decision was to use Playwright in headless mode for speed and resource efficiency. The Playwright.sync Playwright Context Manager handles browser instances, ensuring they are properly closed after each scrape, preventing resource leaks. If a status change is detected and that change matches the desired status for that shipment, a notification is triggered. For notifications, Twilio was the obvious choice. It's reliable, simple to integrate, and their Python library is excellent. When a status change meets my criteria, my system calls the Twilio API. The core of this is client.messages.create to equals notify phone number, from equals Twilio number, body equals message body. The message body is dynamically generated, including the tracking number, the carrier, and the new status. I also include the previous status for context, shipment tracking number for carrier changed from old status to new status. This provides immediate, actionable information directly to my phone, letting me make decisions without manually checking anything. Error handling was a significant part of this project. Web scraping is inherently brittle. Carrier websites change their HTML structure without warning. I implemented try-except blocks around all Playwright interactions, specifically catching timeout error and generic exception for unexpected page layouts. If a scrape fails for a specific shipment, I log the error, mark the shipment as failed check in the database, and set a longer retry interval for that specific entry. This prevents a single broken scraper from halting the entire polling process. I also added basic retry logic with exponential backoff for transient network issues or rate limits, though Playwright handles a lot of that under the hood. This entire system runs on a small virtual private server, costing me about $5 a month. The Twilio SMS messages are incredibly cheap, usually a fraction of a cent per message, so my monthly Twilio bill rarely exceeds $1. The time saved, however, is immense. Instead of constant manual checks, I get a precise, immediate notification only when I need it. This project has been running reliably for months, demonstrating how a targeted automation with a few simple tools can solve a real-world, frustrating problem with minimal ongoing cost. If you're tackling similar web scraping challenges or building custom notification systems, let me know in the comments what tools you found most effective. Next time, I'll be sharing how I'm using Playwright for a completely different kind of data extraction, focused on local business listings.